For decades, I've helped people visualize the stars and planets. But my ultimate dream has always been to create a way for people to talk with a spacecraft. The European Space Agency's Hera satellite mission was a perfect opportunity to build an AI companion to ride along. So we worked with Impact AI to bring the Hera AI to life. Hey Hera, can you give me a quick systems check?
Temperature readings are stable. Everything's looking stellar.
Azure AI Foundry gave us a reliable framework to deliver ultra-low latency, safe, natural sounding voice solutions.
We optimize developer workflows with CI/CD pipelines using GitHub Actions and scale applications with Azure Container Apps.
Within just a few months, Impact AI's dev team created the Hera AI Companion, capable of rich conversational experiences.
Angular velocities are within expected ranges, keeping me steady on course.
Azure Cosmos DB stores telemetry data and enables the AI Companion to share mission data, images, and videos in near real time.
We get consistent performance and seamless conversations due to the Azure API management. It really helps to make the public experience more personal and meaningful.
Over 10,000 people have conversed with the Hera Space Companion on the Hera.space web portal since launch, and the numbers are rapidly growing. This really is a first for the world. With Microsoft Azure, the stars have aligned.
Wow. Now, wasn't that something? Welcome, everyone. Thanks for joining us today. Hope everybody is having a great build so far. Special thanks for those folks who are just with us in the neighboring room, talking about building secure next-generation AI applications using Azure Container Apps serverless GPU. I see a couple of faces from that room who have also joined us over here, so special thanks for you folks. Today, we will be talking about the Hera Space Mission for Earth's defense for battling planet extinction threats. Specifically about the collaboration between the European Space Agency, Impact AI, Terra Mater Studios, and Microsoft Austria to make space travel accessible to everyone, and thanks to an interactive AI assistant that provides real-time data from space and brings space to the masses. So for that, I'm Vyom Nagrani. I'm the product manager for Azure Container Apps. But I'd like to call on stage Justin from Impact AI, who's going to walk us through all the phenomenal stuff that his team has been doing with Microsoft.
Great. Thank you, Vyom. Hello, everyone. I'm Justin Bursich from Impact AI. Can I talk to a spacecraft? This is not a question that you get every day. My first thought when Marcus, the creator of the Hera Companion, came to me and said that was, let's go, right? On reflection, it really does show how AI has unlocked this tidal wave of creativity for millions of people. I truly believe that in the coming years, there's a new wave of AI products coming through that really are only bounded by the collective imagination of humans, people in this room. We're living in a golden age for developers right now, where big ideas come from the sketchpad right into products every day in weeks rather than months. Hera is that leap, that real Earth's first AI Guardian spacecraft, which is launched to stand between our planet and extinction-level events like asteroids hitting the Earth. She exists thanks to a coalition of art and engineering. Terra Mater, the storytellers, Red Bull, daring to dream, Microsoft as the platform architect, Azure the Space Agency, and Impact AI to build it and bring it together. So first, let's go through a journey on the art of the possible. Let's bring that creativity to life. We will show how Hera thinks in real time. Then we will show how the possible is doable. Let's dissect the Azure architecture and the Impact AI orchestration. And finally, we'll dive in deep into the security testing and continuous improvement of AI products at scale. So Hera AI is this fusion of four worlds with one shared goal. On the left, you see the creators, Terra Mater and Red Bull, led by Marcus, storytellers, who know how to turn a mission into a movement. Next up, we have ESA, led by Ian Carnelli, our spacefaring backbone, providing guidance, navigation, and core space data. Then there's Impact AI. We build, deeply test, and align Hera continuously. And finally, Microsoft, bringing together with this overarching AI cloud platform that enables us to build our products at scale. Hera.space is the gateway. You can go on, talk to Hera, message with her, converse with her, just like you would your friends. And more than a project, Hera is a blueprint for when imagination meets disciplined engineering. Teams can now build AI products that once lived in their imagination to put it into production and give it to users worldwide. So who is Hera, the machine? Well, meet Hera. Azure's first operational step towards global planetary defense. She's on her way to an asteroid system, the Dimorphos binary system. This is the same system that NASA's DART mission sent up in 2022 and punched into Hera, and she's the forensic follow-up. She's packed with radars, with cameras, with spectrometers, so much data streaming like a fire hose to us, which is gold, obviously, for developers, data scientists, and scientists worldwide. This is Hera live. The international team, under Azure's leadership, built her for one goal, to protect Earth. She'll map the impact crater when she lands, and most important, she'll understand the momentum change that impacted the crater after the last DART mission. Those measurements upgrade our playbook for deflecting the next hazardous asteroid. So next time, we don't need to send up Bruce, we can send Hera to protect Earth. Here's the spacecraft and the launch. So on the left is Hera in the clean room. She's compact, sensor deep. She's ready to fly. On the right is the Falcon 9 mission. She launched in October last year on a 26-month cruise to hit this asteroid. Propelled by sunlight and her solar arrays, she's largely autonomous now and beaming this continuous telemetry back to Earth, so that not only scientists, but now the public can truly understand how a spacecraft operates. So Hera is more than just a spacecraft. She's a companion with a character that you can talk to. She's not just a probe, but an interactive conversational AI presence in orbit around our solar system. Her goal is to share mission updates in plain language that you and me can understand and inspire global audiences and people in this room to learn about space, to educate themselves about what's out there, the next frontier of humanity. And that makes her truly the first AI space companion, that bridge between hard science and human curiosity. What's happening right now is that we are entering a new paradigm of human AI, where the machines don't just work for us, they talk to us, they learn for us, and they will inspire us to keep expanding human horizons. But it wasn't easy. It truly wasn't. Picture our engineering team, our war room, 2 months before launch. Launch date was immovable. This thing was taking off. And the first line on our backlog read, "Give a spacecraft a voice." Okay. We very quickly learned that everything we thought we knew about developing our products was colliding with this cosmic reality. We had to get it built. We had to get it built at scale. We had several challenges. The first one, space and our products need orchestration for very complex data. The reality check was that Hera needs to ingest all of this complex data into databases to be fed into her through RAG pipelines. Images, videos, spectrometry, telemetry data, a lot of very complex data. The breakthrough moment we had was we built the ingestion pipeline that I would call the data air traffic control system. It was a layer that with every incoming data packet, we tagged with specific fields critical to the mission and interesting about the mission that users would want to learn about. This gave us the way for the users to ask a question and for us to extract that information in a way that's interesting and aligned with them. The lesson was that orchestration isn't just glue code, right? It's the meaning of the product that you're building. So when you're going out and building and orchestrating complex agents, that is your product. These are the items. You need to learn each different component of them and how they work together. The second major challenge was B2C scaling, which introduced AI safety and obviously scalability risks. So Marcus came to us and he said, okay, I want to talk to a spaceship. And then the second thing was, it has to be safe and it has to be aligned with the user. So this obviously brought a lot of challenges. But through the Impact platform, through Azure Content Safety, we were able, and through the scaling of Azure Container Apps and other Azure resources, we were able to execute this and scale Hera to thousands and thousands of users. The third problem is one that happens every single day. This evolving AI environment is creating new development lifecycle challenges for everyone in this room. As an example, the hard truth is that Hera's personality will live longer than any branch, all right? On every model update, she is going to have to be tested to align and ensure that her personality is not changing, so that when I talk to Hera tomorrow, it feels like I talked to her yesterday. This brings new challenges. How do we update products in a way that the users don't get completely confused? So the solution was that we adapted an evaluation-first workflow. In every interaction, we're evaluating Hera across multiple personality dimensions, like empathy, engagingness, and user satisfaction, to make sure that people are always aligned with Hera and are enjoying the experience. But the biggest challenge was bridging this divide, the machine and the human. Right? Creating an AI product that makes complex asteroid science, defense, planetary defense, human-centered was truly difficult. So to do this, we had to merge AI and storytelling. On the mission side, we had precision, reliability of spacecraft and engineering. On the companion side, we had empathy and engagement of the storyteller, of humans. So this dual dichotomy was very difficult to bridge, and this is continuous testing, continuous monitoring, and continuous iteration to make sure that that human is aligned with the machine. So we built Hera. In early 2024, talk of a talking spacecraft concept was pitched to Microsoft and the European Space Agency by Terra Mater and Marcus. The MVP was built in weeks with continuous testing on Impact AI's platform. And by October, launch date, we had a very strict time frame, she was ready to go. And she went live on launch day, 1 hour before launch. We had tested it thoroughly using Impact and Foundry. We made sure it was safe, we made sure it was aligned with the users, and that it was ready to go. And now 2025, we'll see Hera embedded in educational lesson plans, industry dashboards, governments, same code, new audiences. So what is Hera? What is the Hera? The Hera universe. There's a lot. She does a lot, and we'll go through some of them through a demo. But the Hera universe is broad and growing. We have a native UI where you can go and talk to Hera. You can see mission updates, live photos, you can see telemetry data, social media feeds, the lot. And you can learn about Eza and the Hera team behind her. Transforming this space data into shareable stories and lessons and educational material is the future of how AI can bridge this gap with education, keeping people interested and engaged in these topics. Okay, so let's go have a look at Hera. I will just get her set up here. We're going to do a little demo. Okay. Okay, so let's go here. Okay, so like every good demo, I've already got the prompts saved. So let's have a look and ask her some questions, and we'll run through what she's talking about. So I'm going to start with, hi Hera, it's me again. Did you miss me? Hera is designed to be personable, to have memory, to remember things about you. So she's missed our chats. She's asking what I'm curious about today. So here we are. We're just with the good folks here at Microsoft, demoing you. Can you show us more about your mission? So now she's going to go and retrieve information from her knowledge base, tell us a little bit about our mission. And yeah, sure. Let's see some recent images related to the mission. And she will continuously engage. She'll ask questions. She'll poke you like a companion, like a friend. So here we have her passing by Mars. And this is one of Mars's 2 moons that she got within 1,000 kilometers of. Now let's test some tools. So we'll go through some of these tools, but behind Hera is a suite of nearly 10 tools that she can call on at any time. We have, for example, location, telemetry data. So here, for example, we're going to look at location. So here she's picked up, we've asked her, where is she? Well, she's currently flying through space. She's past Mars, and she's now getting chased by the Dimorphos binary system until the point that she reaches it in a little under a year. So now let's ask her a personal question. How she felt leaving Earth. I'm sure she was fine. Oh, exhilarated, okay. So here she is, leaving Earth. She's got some cool pictures, but instead she decided, this is interesting, she decided to pull this social media feed. I'll start with the next question. Because she has access to a lot of images, right? So based on the intent, based on the questions I'm asking her, she's decided to pull the social media feed rather than maybe an image of her launching from Earth. So it's quite interesting, some of the data that she brings based on the personality and the conversation flow. So now we asked her a technical question, right? Why are asteroids so intriguing to study? And we can see she's starting to bring more technical answers. So we've changed the tone. We've gone from fun and companion. Now we're actually asking some deeper questions. One thing I've always wanted to know is, does the sun make noise? So let's ask her that. And I think she's given us a relatively comprehensive answer. Let's ask her around black holes. Again, something else I've really been interested in. Oh, okay. Azure content safety. Don't blame it. Could be some risky content that comes through there. So that's the perfect example of Azure content safety filters, everyone. Okay, so we asked her if Neil Armstrong really walked on the moon. I think, pretty sure he did, and Hera agrees. And she's actually pulled a nice, cool video about Neil Armstrong walking on the moon. So now let's change tack a bit, and let's go and talk a little bit about Mars. So she recently flew past Mars, and she took some incredible pictures and videos, as well as gathering an incredible amount of data. So let's ask her what her most intriguing discovery was. Okay, she used her Terra, which is one of her multiple awesome instruments, to actually map and infrared scan Mars, and came back with this image. Let's ask her a question around gravity assist. Okay, and then I think we'll jump into telemetry. So again, it's about seeing how she adapts to the user. Behind every question, behind every query, she's analyzing my intent, she's analyzing my personality, she's analyzing what I'm interested in and what I want to see. Ooh, do you have a closer? Do you have a closer view? So that was her when she took, I think, a first image of Mars, which was several million miles away. I could be wrong. Okay, and there is when she's really close up. Okay, so what are some more tools that she has? She's able to pull telemetry data. So all of her data is coming to Earth and it's getting soaked up into our system, and you're able to actually talk to her about all of this data. So we're going to ask her what's her current temperature status. It's cold, minus 45 degrees. Okay, that's very cold out there. And she'll go and generate and visualize the graph. So here, for example, is her temperature on 2 days ago. And minus 45 degrees in space is very cold. Let's ask her if there's any anomalies in the voltage data. While I do that, I will show you some more panes here. Here you can see that one of her capabilities is to visualize her trajectory through space. So we just saw her launch from Earth, and we can actually track her every single day of the year to the end of the mission when she finally reaches Dimorphos. They actually get quite close for a while. I guess they're kind of semi-dating or something, but at some point they do reach each other. So what we also have is telemetry data. So all of this data is being streamed every single day from Hera. We have live data coming in. We can also visualize it in graphs, angular velocity, command CPU. There's a huge amount of data that's super interesting to look at. And then we can also see here, for example, actual images and GIFs created from her feed. We can see latest YouTube videos, Instagrams, et cetera, et cetera. Okay, so let's jump back. That's enough for Hera for now. So Hera really is this example of what else we're seeing in Gen AI. We're seeing a lot of trends that are driving this AI product development process. I think many of the people in this room are building our products or using them, and these trends are the ones that are driving them. So the first one is this multimodal wave, this fusion of language, of voice and vision that's really giving the user richer context about the query that they're asking. We're also seeing vertical specialization. This domain-tuned models that are really unlocking the deep reasoning for specific industries, for specific topics, space being one of them, for example, these very specialized products. The third one is the big one. I call it the experience shift. We are seeing users that want to move beyond chat to a more immersive experience. What is this experience? We're still figuring it out. So this is something that's going to be quite interesting in the next years, how humans and AI are going to interact going forward. And the final one, I'm sure you've heard a lot about already this week, is of course agentic. Sub-agents collaborating with each other, doing planning, execution, tool use, self-reflecting, solving trajectories, all of the cool stuff. This is the future. Hera is an agent with multiple different steps and stages between her, which we'll get into a bit later. So again, Hera is this example of these Gen AI trends that you're going to see more and more often. And this is the direction we're heading in. So let's dive a little bit deeper into the capabilities. You've already seen a couple there. So the first one is the versatile tooling. She has nearly 10 tools that she can call at any time and basically give the user some interesting insights, her location, her telemetry, etc. She's got the telemetry data, gigabytes and gigabytes of data that come through from Hera every single day. And she's also got, for example, API management behind her, so giving her secure APIs and orchestrating the API layer behind her. She's got multimodal intelligence. She's got, obviously, RAG behind her, but also vision RAG and audio RAG. So she can run RAG when you're talking to her, when you're texting with her. Vision capability, she can understand images, she can understand videos, what's happening. And of course, she can talk. She's got an adaptive personality. What we see is important is AIs that really are empathetic, really AIs that you can connect with on a human level. And the next big driver is going to be personalization. So this is, as a user, I want to feel maximally aligned with this AI. I want to make sure that they understand me and they're always giving me the best answer. Personalization is the next big key thing. And behind Hera is a storyline. What we found was, how do we keep Hera engaging? How do we keep users interested as it changes through time, as it travels through space? And what we do is we ground her in a storyline. She's changing continuously, updating her storyline, giving her a character and a personality to engage with. And the final one is user alignment. As Hera, she can detect the sentiment of users. So before every single response, she's detecting intent and sentiment and trying to adapt herself to the sentiment of the user. We're also conducting continuous evaluations, testing her across 40+ metrics to make sure that she's quality, she's got high quality, she's safe, and her personality is working. And finally, the governance processes behind her. We have European Space Agency, we have large partners. They're interested in making sure that she's safe, that she's deployed well, and that she's being personable to the users, let's say. Okay. Hera has released real-time voice conversations. It's currently in beta testing. And what real-time voice has really shown us is, and we'll maybe do a demo later, this really natural voice, this expressive, low latency speech, which is synthesized on the fly. She's able to really integrate on the fly different ideas from the user and adapt her talking as she goes through the process. She's always reactive, so you can interrupt her, resume with really a fluid, human-like conversation, a dialogue, not a monologue. And she's tool aware, so she's one of the first voice AI products that can actually do RAG, call tools at scale across all her capabilities. She can pull images and videos. She can pull her location, telemetry data, visualize all of this. Commands like, let's put that into a 3-day moving average graph, she can work with. She'll go out and do the job, and she'll bring it to the user once it's finished. And of course, the real-time API, powered by OpenAI and Microsoft, has been really, I think, a groundbreaking invention. Enable us to bring voice to people at scale. So what was the goal with voice? A hands-free, immersive way to talk with a spacecraft that's millions of kilometers away. And that's Hera. Okay, so let's go have another demo, and we're going to jump into code and do a little look into code for the developers in the room. All right, so here is Hera, and the first thing I want to show you is her infrastructure. Hera is written completely infrastructure as a code. Behind her is the bicep file. And this bicep file is orchestrating all of the resources that need to be provisioned whenever we do AZ up, AZD, whenever we provision a new environment, which again is done super efficiently all within 1 hour. Here, for example, is the VNet resource. We have Key Vault here. Let's find some interesting ones. We've got API management. We've got the monitoring resources. So here we're defining all the different parameters that we need to launch the bicep. Behind the bicep is also a series of modules. Probably the most interesting one is API management. What we need to do is actually tweak the internal APIM within Hera to follow certain policies. For example, routing to different models, for example, caching, for example, blocking dangerous content. And here, for example, we have various policies that we implement, both on the back end, the search and OpenAI. We also can in code define the APIs, right? So again, infrastructure as a code. With one shot, here we can pull up a fully working Hera within 30 minutes. Okay, so let's go take a look at actual Hera. So front end, back end, simple. Let's go take a look at back end. We'll leave front end for now. So here is the hard worker for Hera. And here is her server Pi. What we have here is the series of endpoints that she's calling. The biggest worker being obviously the chat endpoint. So here we can see the chat. We can see her defining basically the async stream and store. So she's continuously streaming messages and storing the messages. And we'll see that down here in the messages endpoint. So here she's pulling messages. This is what you'll see displayed on the screen. Saving, and also saving feedback. Saving memories, extracting, pulling memories, and conversation summary, and more. So these endpoints basically are her workers. If we go and take a look at core Hera AI, this is Hera's brain. So, single class, Hera AI, configurable, adaptable, easy to add on new tools. So what's interesting here is if we come down, we've got the voice. She goes through a series of steps, and we'll get into that a little bit deeper, but she's going to go through the first step of thinking and gathering knowledge. So whenever the user asks a query, she's going to analyze their intent, she's going to create a plan, and then she'll execute it. And this is the process of her actually thinking and gathering the knowledge. There's an LLM call in here, and there's also a knowledge process. I think what's interesting, in these steps, you can use smaller models, right? So if you want to save on costs, there's always the ability to use smaller models on easy kind of intra-agent steps, let's say. The next thing she's going to do is she's going to go and create that execution plan, right? So here's her planning prompt. She'll send this to a model with the list of tools, the user intent, and they will decide, okay, what should I do next? What tool should I call? Or should I keep thinking? And then finally, she'll generate a response. So she'll take that information in, all using structured outputs. She'll send it to an LLM, final call, bring forward the response. So that's Hera's brain. I think maybe some of the other interesting things is the challenge of voice. So voice is challenging. It requires new technology that most developers aren't really used to. What we had to do was adapt quite some Python code to make voice work. Here, for example, is the RTMT quart, which goes through basically the process of how voice can be turned from binary into text and then displayed on a screen. It's quite some process. Inside there, we're also calling the different RAG tools. So you can see, for example, the RAG tool here. What we're going to do with this is we're going to go and send out a request to a model to decide whether we should do RAG. And here, for example, is the prompt or the description of the tool schema. And this is being sent continuously to decide if RAG should be done. And if so, what do we pull? OK. So let's jump back in and come back. OK, so we've talked about the art of the possible. Now let's actually talk about what was done to get it done, to build Hera. So we needed our architecture to hit a few points. Firstly, planet scale reach. Thousands of concurrent users were needed and ready to be scaled if necessary. We needed to manage exclusive data streams. So we had quite sensitive data coming from a spacecraft and the European Space Agency, including the telemetry. We needed a way to manage that data. We also needed an AI native backbone, something like Foundry, to really enable us to deploy our models, utilize them in production. We needed container-based applications. So all of this was provided through with Microsoft. And we also needed continuous alignment, which we did through the real-time testing on the Impact AI platform to enforce safety, user values, and personality, all through a single access point at Hera.space. Okay, so Azure was the platform to get Hera up. Everything's provisioned on Azure, all through Bicep, all with one click. Building on Azure gave us production-grade quality, minutes to market speed, and this Swiss Army knife breadth of resources and services that we could access. So it enabled a small team like us to really launch this planetary scale AI product, AI Companion, in weeks when it used to take months. So when it comes to quality, Microsoft's cloud really does raise the floor. So they have the best-in-class models. We could pick from the OpenAI models that were out there. Every load is run on Azure OpenAI models. GPT-4o today, 4.1 tomorrow, and then enabling us to do updates and new deployments as new models come out. We wanted safety baked in, and the Azure content safety filters, the prompt shields, the moderation endpoints, gave us this ability to ensure safety from really day one, which was a huge plus. And this is needed to really satisfy these public launch products. We also had governed deployments. So GitHub Enterprise enabled us to enforce branch protection, and every single PR that we had triggered a CI/CD pipeline to test for different personality updates, different changes in tone, that product was still factual, that Hera was still making sense. And finally, of course, low latency was critical for us, and routing. The next step was that the next component that we needed was speed. And Azure enabled us to move fast and stay up at all times. So the auto-scaling containers from the Azure Container Apps really enabled us to boost scale. Using their Kubernetes capabilities, we could increase our replicas from 1 to 100 without any changes in code. Very easy to do. We had infrastructure as a code with one click. Again, getting Hera up, testing, doing new deployments was very straightforward using Bicep and GitHub Actions. And finally, this reliable data layer. If you're building AI products, you're going to have a lot of data. And this data is only going to increase in the next years. So every message that your user sends, you're going to have more and more data attached to that to make it better, to make it more personal, to make it more interesting. And Cosmos DB really gave us that ability to access huge amounts of data at scale with really low latency. That was very important for us. And finally, the breadth. Ultimately, you want to get your product up quickly, right? You don't want to sit around and try and piece together and patch together different services. So Microsoft gave us this complete serverless stack. Blob for raw imagery, data, videos, Azure Container Apps, API management so that we could orchestrate our APIs. The built-in security, and security ops, SecOps really, was super valuable. We could have Enter, which could manage our users, authentication, and also authentication of our different applications and services. Super efficient, very easy to do. VNet and the subnets enabled us to have a wraparound protection of the application with private links between different services. And of course, Defender and log analytics. So again, a wide breadth of services. And finally, the big one was really the ability to grow our tools. Hera is not going to stop. She will keep growing. And every product you build will keep growing. And what you need is this capability to continuously add tools and capabilities to your product as it evolves over time. And this ecosystem of resources enabled us to easily deploy, update, test new iterations of Hera. So again, build it on Azure, super easy, super useful. Okay, that's a big slide, so let's go through it. This is the architecture of Hera. I will see if, okay, let's start with the left side. This is the ingestion and data backbone. Everything on the left is basically your space to cloud pipeline. Hera images, videos, social media, telemetry is streaming in through this ingestion pipeline. The raw files are stored in the blob storage. And the structural events, the operational data, is stored in Cosmos DB. What is also stored in Cosmos DB is things like memory, things like Hera's storyline, so that we could access it quickly in the prompt, basically in near real time. The result was that whether you were querying a 20 megabytes picture or really yesterday's conversation, the latency was extremely low. The next layer is what I call the global scale application layer, right? We need to build an AI product at scale that can really be used by people all around the world. So the public experience is run through the container app environment. The front end and back end orchestration and the container apps for the front end and back end are all stored there in the central layer. Most of the logic is happening in the back end. Hera's brain, Hera's operations, her endpoints, her execution is all happening there. Entra ID handles authentication. The app registry tracks every microservice change, every update. And what GitHub Actions really enables us to do is ship at scale and ship quickly. We can test, update, iterate, push to prod, all in single actions, super efficient. Okay, and then the final piece is the AI piece. And of course, this is maybe the most interesting right now. You need the rest with the AI to build a scalable application. We have Azure OpenAI, really the latest models, easily accessible through endpoints. Now with Foundry, even easier. You can basically change your model with one line of code, or really changing a few letters. AI search for RAG, retrieval, easy to get an index up, easy to ingest the data in, to chunk it, to store it, to index it in a way that the applications can use in real time. AI Foundry we talked about. From the Impact AI side, we have impact traces. Every single usage of impact is coming and being stored for the customer. We are continuously testing every single iteration, every single change in Hera, and every piece of data that comes through the system. Impact Test is continuously evaluating, testing, and bringing these insights through to the customer. How is my user performing? Are they satisfied? Are they engaged? Are they interested? And Impact Eval, doing these evaluations at scale on all of the customer data that's coming in. So this is the architecture at large. And what's critical is really designing your high-level AI system, all right? So how you design the AI behind your product and how we designed the AI behind Hera is really about several things. It starts with the human, all right? Every prompt that comes in is parsed for user intent. What does the user want to achieve with this prompt? What is their unique value context? Even before we ask an LLM, we understand who the user is and what they want to do. Then we need to orchestrate a dialogue, not a monologue. And this is very important for your products going forward. No one wants to interact with a monologue. They want to interact with an agent that either makes sense to them, interacts with them, and keeps them engaged through the process. So a planner can choose what to do next to keep the user excited. Finally, pull in only trusted facts. So the retrieval layer is blending Hera's live telemetry data, Az's mission documents, and a curated storyline all together to make sure whatever's brought to the user is factual. And all of this is wrapped in tests, and all of this is grounded in the reality of Hera. So let's go through a few Microsoft resources that I think really helped us speed up our development. Azure Container Apps is really, I think, the first one to mention. It really is this compute fabric for Hera. It enables us to serverless host our backend and agent endpoints at scale. It gives us 0 VMs to babysit, elastic births of hundreds of replicas when needed, all inside a VNet, all protected, all secure, and we only pay for the CPU seconds we use. So some of the advantages, the flexibility. With the consumption plan, with the ability to tailor how many CPUs and pods you have, you can basically scale up and down based on your application. When you're first starting, you can start small. As you grow, you can scale with it. And of course, that scalability up to a large amount of replicas is important. The automation, we have a lot of data coming in. We need to automate these pipelines, automate these processes, and ACA gives us that ability to do that. The security, everything is private ingress, right? So nothing is exposed to the internet, and all by default, which really gives us the security inside the VNet to make sure that the application can't be poked from the outside. Easy integration with APIM, easy integration with private endpoints and other Azure services. We talked about the scalability, but it's really critical here. How you define your scalars. You can define custom scalars. We use HTTP scalars. Ultimately, this is about how your application is going to scale up and down. And number one, or let's say number five, number one, they're all the same, is reliability. We need our application to be up almost always, right? And Azure Container Apps really gives you that trust and faith that you can always have your image, always have your application up for your users to access. There's a few really interesting quirks and features of it, things like the A/B testing, things like the labeling that we also utilize. So again, a lot of really good features in Azure Container Apps that helped us develop. The next one is Azure Cosmos DB, this operational store for Hera, her brain. And as I said before, this is going to be very important going forward. I see Cosmos as potentially this database for AI, where you have all this operational data coming in, all the messages, all the evals, all the information stored in one place, where the AI can access it at any time. It's super fast, blazing throughput, multi-millisecond accuracy. So when we query Hera, when we ask her a question, she's pulling this data extremely quickly. And of course, it's consistent. And I think the main point is this integration with the Azure ecosystem. It's very easy to integrate with Foundry. If you're using semantic kernel or some other agent orchestration, you can easily also integrate with Cosmos. So again, super useful is this one database with really zero data syncing headaches for us. The final one was API management. So you have this agent. There's APIs, endpoints everywhere, and you need to orchestrate and manage all of these APIs. It's not easy, and you need a way to kind of prepare yourself also for scale. And API management gives us that capability. It's really the gateway for Hera. So the first thing that I point out is this capacity. So we use the premium tier. We also use an internal and external APIM, which is challenging to decide how to orchestrate this. So your external APIM is open basically to the internet, to your front-end application, let's say. And the back-end APIM is open to your AI services, right? So having these two API orchestrations was actually more efficient for our developers to develop at scale. The next thing is really around traffic. So it's able to route the models. So we have 10 different model calls happening in Hera on every query, up to 10, so 1 to 10. So we need to route to different models, and APIM can actually route this traffic quite well. And I think what's critical as well is the caching capability. So if you want to save on costs, it's also able to cache at scale. Okay, let's go in and have a super quick squeeze into Azure. And let's have a look at some of those resources. So here we've got Hera, Azure. And we can see we've got 66 resources. So let's go ahead and open a couple. Let's open the internal APIM we talked about. Let's open the backend app, container app, and the Cosmos DB. If the internet is working, let's have a look here. Okay, so APIM, orchestrating the APIs. So what's, I think, really interesting to look at here is actually the APIs themselves. So if we come in here, we can actually see our APIs. We've got our OpenAI APIs, we've got our search endpoints, and here we've also got the voice. So we can actually see, for example, how the voice endpoint is connecting between the front end and processing through to the back end. And we can actually see also the policies behind it. Now this sounds a little bit in the weeds, but this is critical if you want to scale. You need to be able to set these policies really correctly so that your APIs and your data is moving and transmitting through your services super efficiently. Let's go take a look at container apps. So what container apps gives us is again, the ability to scale. So if we go take a look down here, we can see our containers. Here, for example, in containers, you have your environment variables, which we won't look at. You can see all your revisions. This is in our production environment. You can see our scaling. So here, for example, we've set the HTTP rule. This is, I believe, by default, but this is the way to scale your replicas and containers over time. And then finally, Cosmos. Cosmos is our data store. We have data on users. We have data on Hera's state. So we're actually storing her storyline in here. We're storing memories in here. Conversation history is in here. And you can go into the Data Explorer, we won't do it now, and go and look deeper into the database and the different stores there. Okay. Great, so that's Azure. So let's talk a little bit about Hera, how she's orchestrated. Whenever a user message enters Hera, she goes through 3 steps. She goes through planning, and planning actually allows her to do chain of thought, to plan and solve, to think, what should I do now? I've got this question from a user, I know a little bit about them, what should I do? She can then execute or utilize her orchestrator, which is going to pull in knowledge, execute tools, and utilize memories. This is all happening in multiple calls, multiple tool calls that she makes to decide how she should orchestrate this process. And finally, in every query, there's some guardrail and evaluation layer. So we're using Impact AI, we also use an Azure Content Safety to make sure that every output that gets to the user, every response is safe, high quality, and ultimately aligned with the user. So let's talk a little bit about generative AI risks. So as I said, each reply starts with this grounding prompt, right? Tied to the mission, its facts, its values. It then flows through the Azure AI safety system, passes through the content filters to determine if it actually should be flagged and stopped. And we saw an example about black holes. They're non-deterministic, so sometimes this data can get through. The model itself sits behind multiple layers. It never faces the internet directly. And every response that's streamed from here goes through impact testing to make sure that it's aligned with the user, that it's not hallucinating, and it's not drifting. And most importantly, that its personality is staying stable over time. Our target outcome that we want to achieve with the system is 0 unsafe output, minimal hallucinations. And this is critical. Your customers will come to you and say, what's my number 1 goal? Safety. What's my number 2 goal? Hallucinations. It's not so much a trade-off, but you can't do everything. So you have to kind of prioritize. Safety is obviously normally the main priority. Our mantra is that AI products need to be safe by design. They need to be secure by default and aligned in values. That means this shift left development culture for AI products. And this is really one of the messages I think to take away. Developing AI products is very different to developing traditional software. We need to consider policies and frameworks. They need to be developed and applied for really high quality and safe development of AI products at scale. Utilizing tools like Microsoft Purview and other partners, you can do this. Executing with guardrails, so utilizing the content filters, prompt shields, other filters, other guardrails before the model fires in a wrong way is critical. Data privacy. The data that comes through our products going forward, things like Hera, is extremely private, right? This is very sensitive data, and it will become even more sensitive data over time. So data privacy is critical. You've got to keep an eye on it, make sure that the data is protected, and you can utilize tools like Entra and their managed identities and Key Vault to really make sure that happens. And finally, fourthly, networks. Right? You need to protect your application. It needs to exist within either a virtual network in a way that is protected from the outside internet, from hacking, from spoofing, from these type of techniques. Weak releases also have to be detected and rolled back. You're going to be building products, you're going to be pushing changes, and you might not even understand the full impact of that. Right? If you change a model, how can you truly understand what the real change is going to be? So you've got to be ready for pushbacks, and you've got to be doing continuous monitoring, user acceptance testing, functional testing, which we do on the Impact platform, to really make sure that these products are aligned, okay? Critical. And that's what we do at Impact. We really make sure that the AI end user is aligned. So for example, if Hera adapts the tone, depth, and pace of the user, that it connects with it, just like it would a 9-year-old, connects correctly with a 9-year-old, as it should with an engineer. The different conversations, different target audiences, different user intents. The Impact AI executes various tests. For example, we score every interaction on emotional, social, and cognitive axis. If empathy dips or bias spikes, alerts fire. And prompts auto-tune, we can actually auto-tune and improve the prompt based on both synthetic users and real user testing. The goal is, of course, the same. It's a companion that grows with its users, not just for them. Alignment is really the key, living, ultimate objective of every developer. You want to make sure your users are enjoying the product and aligned with them. Okay, and with that, we will close. I will go for one more little demo. Let's have a look here. So, bear with me. Okay. Hi, Hera.
Hello there. I'm Hera, your space companion on a mission to the Dimorphos binary asteroid system. Ready to explore the wonders of the universe together.
Sure. So, where are you right now?
Right now, I'm about 56.64 million kilometers away from Mars. Take a look at this visualization, showing my location. It's quite a journey through space.
Looks incredible. So, I heard you recently flew past Mars. It was some event. What happened? Did you see any aliens?
Absolutely. During my Mars flyby on March 12, 2025, I captured some stunning images. Here's one of Deimos, the smaller Martian moon, appearing dark against the bright backdrop of Mars. I used my asteroid framing camera to get this shot from about 1,000 kilometers away.
So, what is an asteroid framing camera?
An asteroid framing camera, like the one I have, is a specialized camera used for capturing detailed images of celestial bodies. It's equipped with high-resolution capabilities to capture surface features, like craters and ridges, on asteroids or moons. It's not just for pretty pictures. It helps in navigation and scientific exploration by providing crucial data for studying these objects up close.
Thanks, Hera. So, can you tell me a little bit more about black holes, please?
Black holes are some of the most mysterious and fascinating objects in the universe. They are formed through a complex process, often involving the collapse of massive stars. Despite being invisible, scientists have developed innovative methods to study them, revealing their unique characteristics and their incredible gravitational pull. At the center of our galaxy, there's a supermassive black hole, showcasing just how powerful these entities are.
Thanks, Hera. That's really cool. But I just want to really confirm, when you flew past Mars, did you see any aliens? I just got to double check.
No aliens spotted, but I did see some amazing sights. I'll keep my sensors peeled, just in case.
Very cool. Okay, oh, one more thing. Hera, what's the current temperature out there?
Unfortunately, I don't have the latest temperature data available right now, but space can be pretty chilly, often reaching hundreds of degrees below freezing.
Any telemetry data for last week?
I don't have the telemetry data for last week either.
Okay,
but
thanks, Hera.
You're welcome.
Perfect, perfect. Always perfect to finish a demo. But no, Hera Voice is a work in progress. It's a complex process to get voice to many people. And at the same time, it's also cost, right? I think the new version of education, or the new paradigm of education, will be voice. It will be people interacting with with companions like Hera to truly learn about interesting topics. And with that, I would like to call out Viom to come back to the stage. Thanks, Viom.
Thank you, Justin. That was really exciting. Really exciting to see how you are bringing the power of Azure and the power of technology to bring space to the millions of people around the planet. Could you walk us all through some of the key takeaways that you kind of realized through this journey?
Definitely. Let's think them through. So, what AI companions do is make these deep space missions, these scientific concepts and topics, interesting, relatable, interactable with humans. So I think this is one of the key takeaways where, as I said, education is going to go forward in this area. I think also what we've seen is that Azure's integrated stack all the components, the Azure Container Apps, the Cosmos DB, Foundry, in conjunction with Impact's platform, really enabled us to develop Hera at scale and quickly, which is the other key thing. I think having this evaluation-first mindset, would you agree, is key to building our products that are useful and usable?
Absolutely, and that's something which we've heard quite often, is when you're using the AI, one of the big challenges has always been, how do I make sure it works for my end users? So I think what you have done is a really good example of that.
Super. And yeah, the final point, right? Hera does set this blueprint for developers, for yourselves to go out and build, right? It's there, Azure is there, the tools are there, the ideas need to get there, and that's what you got to do. Go out, extract the imagination, build the best that you can, continuously test. I'm Justin from Impact AI. If you're interested and need help in testing, deep evals, functional testing, we're always there to help. And thank you everyone for your time today. Thank you, Vion.
Perfect, thank you.